This is a MATLAB function with a persistent variable and vector interfaces. I want to test it in Simulink. Let me show how I handle the vectors and what it means for the test cases and the report. My filter has the well-defined arguments for inputs and outputs, including ranges and descriptions. And the function also has some persistent variable. It means the function is suitable for testing it in Simulink. With the build harness function, I can build the test object automatically. This function asks you about how you want your vectors to be represented in Simulink for testing. It is relevant for test case generation, reporting, and reviews. You can use the native or the split representation. Let's first see what native means. I click here on native. I will be asked for every interface. You can mix the representation as you wish, and you also can rework the resulting test object the way you need, so you remain very flexible. You get the test object with the title and the description from your MATLAB file. The definition of the interfaces, including data types and ranges, were also derived and are visible. Here we see the dimensions of the vector. The subsystem is fully prepared for EverTest to generate the test harness automatically and start testing right away. In the interface, you see that we have 4x1 vectors. And in the test cases, you see how you will define the values. Let's clean up and run it again. Even as a 4-channel signal, I can debug and read the values on the block labels. But usually I work just on one channel of the vector when unit testing, not on all of them. Let me generate the test object for this function again. This time I will split the vector signals. Instead of 4x1 vector signal, I now have 4 scalar signals. I receive more inputs and outputs, which are named exactly like defined in the arguments block, but they also have indices at the end of the name showing me what's actually behind it. And now if I generate the EverTest harness and start debugging, I will see that I get 1 value per channel. So this is cool because now I can focus on one channel. Based on your use case, you might mix the split vectors with the native representation. But there's a lot of columns in the table, you might say. Right, but you can hide the irrelevant channels inside Excel. Just grab the column in the Excel and move to the left. And focus on what is important for this test case. And you can generate your verification report, which preserves this view. See, the hidden vectors are not shown in the test table, but they did not disappear. See this red triangle over here? It means some values are hidden in the default view of the verification report, but you can open up and display all of these vectors if needed. They are not lost. But for the purpose of the test review, it's very easy now to concentrate exactly on the values that matter. So this is a vector, but I handle just one channel of it. And we think that this is a very interesting, very smart way of handling your complexity. Let us look at the function with a more complex interface. I will split the vector signals. We received a quite complex structure here, nested buses, which also include vectors. The subsystem is now fully prepared for EverTest to create the test harness and start unit testing. Again, I do not need some data for this test case. I can hide it like this. When cleaning up, I can choose whether to refresh the view or to keep hidden columns. In Excel and in the verification report, each column keeps a letter as its unique identifier, so you can always tell them apart. And now I generate the verification report. I also can use the everplot for each signal channel, and my data is not lost or forgotten. I can activate it if needed. Alright, I would be interested to hear what you say about it, and I hope you enjoy this way of testing your MATLAB functions.